Hello everyone. So in the second module of the subject concrete technology, the next and the last topic is workability. So basically workability is a theoretical water cement ratio calculated from the a theoretical water cement ratio calculated from the considerations discussed above and not going to give an ideal situation of the maximum strength. 100% compaction of the concrete is an important parameter for contributing to the maximum strength. Lack of compaction will result in air voids whose damaging effect of the strength and the durability is equally or more predominant than the presence of capillary cavities. So basically here is the figure performed, and this is the slump test here performed, and this is the harsh concrete or the unworkable, medium workable, and the high workable concrete. So basically, workability is a phenomena which also depends the strength and the durability of the concrete. If the workability is low, then the strength is also decreases of that particular concrete just because it gives the capillary or the honeycombing in the concrete. So to enable the concrete to be very carefully fully compacted with given efforts, normally a higher water cement ratio than that calculated by theoretical consideration may be required. So it is clear that for to provide to maintaining the proper workability of the concrete, mainly higher water cement ratio is considered against the theoretical considerations. That is to say that the function of water is also a lubricate the concrete so that the concrete can be compacted with a specified effort for coming at site of work. The quality of concrete satisfying the above requirement is termed as the workable concrete. The word workability or workable concrete signifies much wider and deeper meaning than the other terminology consistency, often used too loosely for workability. Consistency is a general term to indicate the degree of fluidity or the degree of mobility. On concrete, which has high consistency and which has more mobile, need not to right workability for a particular job. So basically, here from this language, it is clear that the consistency and the workability have the different meanings. If we are talking about the consistency, it means the concrete is totally flowable and it have the more degree of mobility, but it doesn't mean that the higher in the consistency of the concrete shows doesn't shows that it is also a right workable concrete for a particular job. Every job requires a particular workability. A concrete which is considered workable for mass concrete foundation is not workable for concretes to be used in roof construction. So basically it is clear that कि जो concrete का use हम foundation में करेंगे जिस flow का या जिस भी वर्केबिलिटी का वो हमारी रूफिंग में या स्लैब में अगर हम उसे वही कंक्रीट यूज करेंगे तो वो दोनों जगह अलग अलग सिग्निफिकेंस देगी अपना. Similarly, a concrete considered workable when used in thick section is not workable when required to be used in thin sections. Therefore, the word workability assumes full significance of the type of work, thickness of section, extent of reinforcement, and mode of compaction. For a concrete technologist, a comprehensive knowledge of workability is required to design a mix. Now we are going to discuss the factors affecting the workability. So here are the some factors which are also affects the workability phenomena. So first one is water content, second one is mixed proportions, third one is size of aggregate, fourth one is shape of aggregates, fifth one is surface texture of aggregates, sixth one is grading of aggregate, and last one is uses of admixtures. So now we can going to discuss in each and every factor of which can able to affect the workability in detail. First one is water content. Water content is in a given volume of concrete will have significant influences on the workability. The higher the water content per cubic meter of concrete, the higher will be the fluidity of concrete, which is one of the important factors affecting workability. At the work site, supervisors who are not well versed in with the practice of making good concrete resort to adding more water for increasing workability. This practice is often restricted because this is one of the easiest corrective measures can take be can be taken at site. So basically, it is clear that it is also added to keep the water cement ratio constant so that the strength remains the same. Water content is also affect the workability of concrete. As we all know, water provides the if higher the water content provide the fluidity of concrete. Next one is mixed proportion. Aggregate or cement ratio is an important factor influencing workability. The higher the aggregate cement ratio, the leaner is the concrete. In lean concrete, less quantity of paste is available for providing lubrication. On the other hand, in case of rich concrete with lower aggregate cement ratio, more paste is available to make the mix cohesive and fatty, so fatty to give better workability. Next one is size of aggregate. The bigger the size of the aggregate, the less is the surface area, and hence less amount of water is required for wetting the surface. So and less matrix or paste is required for lubricating the surface to reduce the internal friction. For a given quantity of water and paste, bigger size of aggregate will give higher workability. The above, of course, will be true within certain limits. So basically, if we are using the bigger size aggregate, it will also improve the workability of the concrete. And but due, in the certain within the certain limits. तो साइज ऑफ एग्रीगेट भी डिपेंड करता है वर्केबिलिटी को अफेक्ट करने में जितना बड़ा ही पार्टिकल साइज होगा उतनी ज्यादा बड़ा वर्केबिलिटी होगी जस्ट बिकॉज वेट रखने के लिए बहुत ज्यादा सरफेस की जरूरत नहीं है ऑलरेडी वो पूरा उसका सरफेस एरिया ज्यादा है और वो पूरा वेट है shape of aggregate the shape of aggregate influences workability in good measure angular elongated or flaky aggregates makes the concrete very harsh when compared to round aggregates or cubical shaped aggregates. So basically ये angular elongated या flaky aggregates हैं ये concrete को harsh बना देंगे compared to the rounded aggregates. Contribution to the better workability to the rounded aggregate will come with the fact that the given volume or weight it will have less surface area and less void than angular or flaky aggregates. तो rounded जो भी aggregate होंगे वो आपके easily bind हो जाएंगे एक दूसरे से against the flaky aggregates or the angular aggregates. Not only that, being round in shape, the frictional resistance is also greatly reduced. This explains the reason why river sand and gravel provides greater workability to concrete than crushed sand and aggregates. So basically, shape of aggregate also affect the workability of concrete. अगर हम rounded shape के aggregate लेंगे तो वो easily surface area भी उनका कम हो जाएगा और बीच में voids के chances mostly कम रहेंगे और against the flaky and angular shape aggregates. This will also clear that the river sand and gravel provided greater workability to concrete than the crushed sand and aggregate. तो river sand जो होगी वो आपकी ज़्यादा workability provide करती है with respect to the crushed sand. The importance of shape of the aggregate will be great significance in the case of present day high strength and high performance concrete when we use very low water cement ratio in the order about 2.25. Next one is surface texture. The influence of surface texture on workability is again due to the fact that total surface area of rough texture aggregate is more than the surface area of smooth rounded aggregates of same volume. So it is clear that जो भी राउंडेड टेक्सचर के एग्रीगेट होंगे उनका सरफेस एरिया ज़्यादा होगा स्मूथ राउंडेड एग्रीगेट से रफ टेक्सचर्ड एरिया का रफ टेक्सचर्ड सरफेस के जो एग्रीगेट होंगे उनका एरिया ज़्यादा होगा विद रिस्पेक्ट टू द राउंडेड एग्रीगेट सेम वॉल्यूम की अगर हम बात करेंगे. From the earlier discussion, it can be inferred that rough textured aggregate will show poor workability and smooth or glassy textured aggregate will give better workability. So it is clear that जो rough textured aggregate होंगे वो poor workability दिखाएंगे, जबकि rounded aggregate होंगे वो आपके adequate या appropriate better workability दिखाएंगे. Next one is grading of aggregates. So basically grading of aggregates, this is one of the factors which will have maximum influence on workability. A well graded aggregate is one of the on which has least amount of voids in a given volume. Other factors being constant, when the total voids are less, excess paste is available to give better lubricating effect. With the excess amount of paste, the mixture becomes cohesive and fatty, which prevents segregation of particles. Aggregate particles will slide past each other with the least amount of compacting effects. The better the grading, the less is the void content and higher the workability. The above is true for the given amount of paste volume. So basically it is clear that अगर हमारा जो एग्रीगेट है वो वेल ग्रेडेड है तो उसमें वॉइड्स जो होंगे पर्टिकुलर एक एग्रीगेट में वो कम से कम होंगे, और अगर वॉइड्स कम है तो उसके लिए ज़्यादा सीमेंट पेस्ट की ज़रूरत नहीं पड़ेगी, और जो कंक्रीट में आपका जितना भी सीमेंट पेस्ट है वो सीमेंट पेस्ट आपका एग्रीगेट के वॉइड्स ना भरने के अलावा जो फ्लूइडिटी है उसकी या फिर जो कि उसकी लुब्रिकेटिंग इफेक्ट को मेंटेन किए रहेगा, और ये जो एक्सेस अमाउंट का पेस्ट बचेगा जो कि आपके कंक्रीट के एग्रीगेट को पोर्स फिल करने में नहीं यूज हुआ, जस्ट बिकॉज प्रॉपर ग्रेडेड आपका एग्रीगेट है उसमें ऑलरेडी पोर्स जो है वो नंबर ऑफ पोर्स ऑलरेडी बहुत कम है, तो जो भी एक्सेसिव पेस्ट बचेगा वो एज अ लुब्रिकेंट काम करेगा और कहीं ना कहीं वो किसी न किसी तरीके से स्ट्रेंथ को increase करेगा ही करेगा. Next one is use of admixtures. Of all the other factors mentioned above, so it is clear that it should be noted that initial slump of concrete mix, or what is called the slump of reference mix, should be about 2 to 3 centimeter to enhance then the slump manifold the minimum dose. One should manipulate other factors to obtain initial slump to 2 to 3 centimeter in the reference mix. Without initial slump of 2 to 3 centimeter, the workability can be increased to higher level, but it requires higher dosage, hence uneconomical. So basically, use of air in training agents being the surface active reduces the internal friction between the particles. They also act as the artificial fine aggregate to very smooth surface. It can be viewed that air bubbles act as a sort of ball bearing between the particles to slide past each other and gives easy mobility of the particles. Similarly, the fine glassy pozzolanic materials, in spite of increasing the surface area, offer better lubricating effects for giving better workability. So basically, admixture जब भी आप use करेंगे air entraining agents का, तो ये एक particular lubricating effect को generate करेंगे for increasing the workability of the concrete. Next one is measurement of workability. So basically it is discussed earlier, the workability of concrete is a complex property. So here are the some of the methods which are commonly used to determine or to measure the workability. The first one is slump test. Second one is compaction factor test. Third one is flow test. Fourth one is Kelly-Ball test, and fifth one is VB consistometer test. So basically these are all are the test or the measurement methods of the workability in a concrete. So we will study each and every method in detail. So the first one is slump test. So basically this is the common test used to measuring the workability of concrete. It doesn't measure all factors contributing to workability, nor it is always representative with the placeability of the concrete. So basically, quality of concrete can also be further assessed by giving a few tapping or balls by tamping rod to the base plate. So here is the apparatus, which slump test apparatus. So here is a cone. So this cone की bottom diameter 20 centimeter or 200 mm, top diameter is 100 mm or 10 centimeter, and the height is 300 mm or 30 centimeter. The thickness of the metal mold should be not be thinner than 1.6 mm. So basically, this is the basics of that part of this instrument slump test apparatus, and here is the figure which indicates the particular dimensions of that cone. So this is zero point 0.2 centimeter or 20 mm thick. This is 1.5 1.6 mm thick, and here is the total height, which is the 30 centimeter. Top diameter is 10 centimeter, bottom diameter is 20 centimeter. So इसमें बेसिकली करते ही हैं कि इस माउल्ड को नीचे से फिक्स करते हैं यहाँ पे इस केस को, नीचे एक प्लेट रहती है, उसके बाद इसमें आप कंक्रीट भरते हैं 3 स्टेप में, पहला स्टेप, दूसरा स्टेप और तीसरा स्टेप। तो फर्स्ट स्टेप में लगभग 1/3 भरने के बाद इसको टैंपिंग रॉड से 25 टाइम्स तक टैंप करते हैं, इस पे hit करते हैं. Then we will apply the second layer of that concrete till here, and after that we again provide 20 times of tamping with a tamping rod, and after that the third layer of the concrete should be poured, and again it will be compacted by or the tamping by 25 times. उसके बाद करते हैं कि इस पूरे मोल्ड को प्रॉपरली भरने के बाद इसको यहाँ से इस हैंडल से पकड़ के ऐसे उठा लिया जाता है. सो अगर कुछ आपका जो कंक्रीट का फ्रेश कंक्रीट का स्ट्रक्चर है वो अगर कुछ ऐसा आता है, दैट इज कॉल्ड द ट्रू स्लम्प. अगर स्लम्प आपका कुछ ऐसा आता है, ये ब्लू लाइंस जो दिखाया गया, देन इट इज कॉल्ड द शियर. एंड अगर आपका ये पूरा इस तरीके से, देन इट इज नोन एज द कोलैप्स फिगर, अगर ये हाइट बहुत डिफरेंस ज्यादा है. So the pattern of slump is shown in the above figure. It indicates the characteristics of concrete in addition to the slump value. It is seen that the slump test gives fairly good consistent result for a plastic mix. This test is not sensitive for a stiffness. In case of dry mix, no variation can be detected between mixes of a different workability. In case of rich mixes, the value is often satisfactory, the slump being sensitive to various and workability. So basically, IS 456-2000 for it is suggests that the very low category of workability where strict control is necessary. For example, pavement quality concrete measurement of workability by determination of compacting factor will be more appropriate than slump, and the value of 0.75 to 0.8 compacting factor is suggested. So basically, this is the method of slump test. As I discussed कि ये एक आपका कोन होता है, इसकी सम डायमेंशंस है, इसमें कंक्रीट 3 स्टेप में टैंपिंग के थ्रू पावर करनी है, और उसके बाद ऑल ऑफ सडन इसको इस माउल्ड को यहाँ से हटाएंगे और जिस भी तरीके का शेप आएगा उस तरीके का हमारा स्लम्प होगा ये. Okay, so by this we can easily decide the compaction factor, which is also in the range of 0.75 to 0.8. The above IS also suggests that is a very high category of workability. Measurement of workability by determining of flow by flow test will be more appropriate, which will teach or study in the next lecture. So the second method of the workability measurement is K-slump test. So basically, very recently new apparatus called K-slump test. So basically, this is the slump test, K-slump tester. Here is the reading gauge, and अगर ये आपका माउल्ड है, इसमें आप कंक्रीट पावर करे हुए हैं, उसके बाद आप अगर इसको उसमें लगा रहे हैं तो जो भी रीडिंग आएगी वो हमारी डिसाइड करेगी स्लम की वैल्यू क्या है या वर्केबिलिटी क्या है. It can be used to measure the slump directly in 1 minute after the tester is inserted in the fresh concrete to the level of the floater disk. This is the floater disk. The tester can also be used to measure the relative workability. So basically this is the here is the figure of K slump test. तो basically concrete आपका एक जगह पे किसी भी उसमें भरा हुआ है या आपका किसी भी बकेट में है, उसके आप 1 मिनट के अंदर 1 मिनट के लिए इसको अगर आप पावर कर देंगे इसमें, then it will the apparatus comprises the following four principal parts. So basically these are the principle of the K slump tester: a chrome plated steel tube with external and internal diameter 1.9 and 1.6 centimeter. This is steel tube which is the external diameter of 1.9 centimeter and internal diameter of 1.6 centimeter. This is the internal diameter where this reading gauge is moves. The tube is 25 centimeter long and its lower part is used to make the test. This length of part is 15.5 centimeter, which includes the solid cone that facilitate inserting the tube into the concrete. So basically यहाँ से लेके यहाँ तक की जो height है ये आपकी 15.5 centimeter है. Two types of opening are provided in this part: four rectangular slots, 5.1 centimeter long and 0.8 centimeter wide, and 22 round holes 0.64 centimeter in diameter. All these openings are distributed evenly in the lower part as shown in 6.3 figure. It means कि ये फिगर अगर आप देख रहे हैं तो ये जो सारी ओपनिंग्स हैं ये सारी यूनिफॉर्म है और 0.64 सेंटीमीटर डायमीटर की है और 22 नंबर ऑफ होल्स इसमें है. ये इसके अंदर अगर 1 मिनट के लिए इसको इसमें सिचुएट कर दिया जाए तो इसकी रीडिंग ऑलरेडी यहाँ पे बता देता है और रिलेटिव वर्केबिलिटी देता है. So basically in this lecture we studied about the workability of the concrete. It means the basics of the workability phenomena in the concrete, in a fresh concrete. And now we are presently discussing the methods to measure the workability, in which there are mainly 5 types of workability measurements are provided in this unit. And the two methods, first one is the slump test and the second one is K slump test, are studied well, and the other three methods to measure the workability will be studied in the next lecture. So the other three methods are VB consistometer, compaction factor test, will be studied in the next lecture. Thank you.